Hello, my dear students. Today we are going to make revision for chapter 1, which is transition elements. We are going to discuss different types of questions and we are going to discuss their model answers. So let us start. The first type of question is to choose the correct answer. The first point, the element in which the outer levels have the electronic configuration 5F14, 6D6, 7S2 is from what type of transition series? Is it first, fourth, second, inner lanthanide? If you think about it, my dear student, you will find that the element in which the outer levels have the electronic configuration 5F14, 6D6, 7S2 is from fourth transition series. Next point, the element in which its outer levels have the electronic configuration 5F14, 5D1, 6S2 is from what type of transition series? Is it first, fourth, second, inner lanthanide? Here the answer, my dear student, the element in which its outer level have the electronic configuration 5F14, 5D1, 6S2 is from inner lanthanides. My dear student, remember that before filling F sublevel, we have to put 1 electron in the D sublevel and then we put 14 electrons in the F and then return to the D sublevel. So this element must be in the inner transition series from lanthanide elements as it is for F sublevel is successfully filled. Next point, the element in which its outer level have the electronic configuration for F14, 5D2, 6S2 is from what type of transition series? Is it third, inner actinide, second, inner lanthanide? If you think about it, my dear student, you will find the element in which the outer levels have the electronic configuration for F14, 5D2, 6S2 is from third transition series. Here the answer, my dear student, you will find it will be third transition series as the D sublevel is successfully filled. Next point, element in which is strong as steel but less dense. Is it scandium, titanium, iron, zinc? If you think about it, yes, it will be titanium. Next point, element which we use in plating metals and leather tanning. Is it chromium, scandium, iron, zinc? If you think about it, yes, it will be chromium. Next point, element which is rarely found in Earth's crust. Is it cobalt, copper, iron, scandium? If you think about it, yes, it will be scandium. Next point, the element which we use in TV photography at night. Is it scandium, titanium, iron, zinc? If you think about it, here's the answer, it will be scandium. Next point, the alloy which is used in the manufacture of MiG fighter jets made of what? Vanadium and manganese, scandium and silicon, titanium with aluminium, scandium with aluminium. If you think about it, here's the answer, it will be scandium with aluminium. Next point, the element which is highly reactive but resists the effect of air. Is it scandium, iron, chromium, or zinc? If you think about it, yes, it will be chromium. Next point, element which is used in reinforced concrete and electricity pylons. Is it scandium or iron or chromium or zinc? If you think about it, yes, it will be iron. Next point. The alloy which resists rust and the effect of acids made of what? Nickel and steel, vanadium and manganese, scandium and iron, zinc and titanium. If you think about it, yes, it will be nickel and steel. Next point. The alloy which is used in the manufacture of a space shuttle made of what? Vanadium or manganese, titanium with aluminium, scandium with aluminium, zinc and titanium. If you think about it, yes, it will be titanium and aluminium. Next point. The alloy which is used in the manufacture of drink cans made of what? Vanadium and manganese, scandium and silicon, zinc and titanium, aluminum and manganese. If you think about it, yes, it will be aluminum and manganese. Next point. The alloy which is used in the manufacture of railway track made of what? Vanadium and manganese, scandium and iron and manganese, zinc and titanium. If you think about it, yes, it will be iron and manganese. Next point. The alloy which is called bronze made of what? Copper and tin, vanadium and manganese, scandium and tin, copper and titanium. If you think about it, yes, it will be copper and tin. Next point. Element which we use in dental implants and artificial joints. Is it scandium, titanium, iron, zinc? If you think about it, yes, it will be titanium. Next point. Element which is used in hydrogenation of oil to produce fat. Is it scandium, iron, zinc, nickel? If you think about it, yes, it will be nickel. Next type of questions. Write the scientific term for the following. Element in which D sublevel is successfully filled. If you think about it, yes, it will be main transition element. Next point. Elements in which F sublevel is successfully filled. If you think about it, yes, it will be inner transition element. Next point. Elements in which 3D sublevel is successfully filled. If you think about it, yes, it will be first transition series. Next point. Elements in which 4D sublevel is successfully filled. If you think about it, yes, it will be second transition series. Next point. Elements in which 5D sublevel is successfully filled. If you think about it, yes, it will be third transition series. Next point. Elements in which 6D sublevel is successfully filled. If you think about it, yes, it will be fourth transition series. Next type of question, my dear students. Give reason for. Alloys of scandium with aluminium are used in make fighter jets. The answer, because scandium is less dense and hard. Next point. Scandium is used in TV photography at night. If you think about it, because it is added to mercury vapor lamps to produce light with high quality, looks like sunlight. Next point. Alloy of titanium and aluminum used in space shuttle and aircraft. The reason, because titanium maintains its durability at high temperature, while hardness of aluminum decreases. Next point. Titanium is used in dental implants and artificial joints. The reason, because titanium is inert substance, so the body doesn't eject it and doesn't cause any type of poisoning. Next point. Titanium dioxide is used in some protection cosmetics, some products, because titanium nanoparticles prevent the ultraviolet rays to reach skin. Next point. Vanadium steel alloy is used in car spring. Yes, the reason, because vanadium gives steel hardness and corrosion resistance. Next point. Chromium is highly reactive but resists the effect of air. The reason for that is due to formation of non-porous chromium oxide layer, which are larger in size than the metal molecules that prevent small reaction with air that we call passivity. Next point. Manganese is not used as pure metal because it is brittle and is used in form of alloys or compounds. Next point. Ferromanganese alloy is used in railway track, if you think about it, because it is harder than steel. Next point. Alloys of aluminum and manganese are used in manufacture of cans, if you think about it, because alloys of aluminum and manganese resist corrosion. Next point. Cobalt is used in detecting cracks and welding connection. Here, the reason for that because it emits gamma rays in which have high penetrating power. Next point. Alloys of nickel and chromium are used in manufacture of heating coil and electric furnace. The reason for that because they resist corrosion when they are heated to red hot degree. Next point. Nickel is used in painting metals because it gives better appearance and also resists rust. Fehling solution is used to detect glucose sugar. The reason? Because its color changes from blue to orange. Next point. Zinc is used in galvanizing metal. The reason? Because it protects metals from rust. Next type of question, choose the correct answer. In the first transition series, the ion, which is more stable when 3D sublevel is half filled, completely filled, empty, or all the previous. If you think about the answer, you will find it will be all the previous. Next point. Maximum value of oxidation state in elements of first transition series occurs in what? Vanadium, manganese, chromium, all the previous. If you think about it, yes, it will be manganese. Next point. In the same period of transition elements as the atomic number, what is increased? Its ionization energy decreases, its diameter increases, it's difficult to be oxidized, its density decreases. If you think about it, yes, it will be, it is difficult to be oxidized. Next type of question, my dear students, give reason for. Abnormal electronic configuration of chromium and copper. The reason for that, because chromium electronic configuration argon 18 for S1CD5. The 3D sublevel is half filled, which have lower energy and extra stability. And in copper, that electronic configuration argon 18 for S1CD10, the 3D sublevel is completely filled, which is more stable and less energy. Next point. Transition metals show several oxidation states. The reason for that, because their valence electrons in both 4s and 3d sublevels are near to each other in energy, that lose the electrons from them successfully. Next point. All the first transition series have oxidation number positive 2, except scandium has oxidation number positive 3 only. The reason for that, scandium has electronic configuration argon 18 for S2 3D1, loses 2 electrons from the 4s sublevel and 1 electron from the 3d sublevel. So it gets an empty d sublevel that is more stable. Next point, the maximum oxidation states of the phase transition series increases from scandium to manganese positive 7. The reason for that, because losing electrons from 4s, then 3d sublevels according to the oxidation state. Next point. The oxidation states of the first transition series decreases from manganese positive 7 to zinc positive 2. The reason for that, because the increase in ionization energy as the increase in the positive nuclear charge. Next point. The oxidation of iron positive 2 to iron positive 3 is easy, while that of manganese positive 2 to manganese positive 3 is difficult. The reason for that, the increase in the ionization energy as the increase in the positive nuclear charge. Next point. The oxidation of iron positive 2 to iron positive 3 is easy, while that of manganese positive 2 to manganese positive 3 is difficult. The reason for that, because iron has electronic configuration argon 18 for S2 3d6, so iron positive 2 has electronic configuration argon 18 3d6 that when oxidized to iron positive 3 has configuration argon 18 3d5, which is more stable since it has half-filled d sublevel, while manganese configuration argon 18 for S2 3d5, so Mn positive 2 manganese positive 2 argon 18 3d5 that when oxidized to manganese positive 3 has configuration argon 18 3d4. Next point, zinc, cadmium and mercury are not transition elements. Here the reason for that, because they have completely filled d sublevel in all their free states and ionic states. In the free states, zinc 30, argon 18 for S2 3d10, cadmium, krypton 5 S2 4d10, mercury, xenon Xe 54, 6 S2 for F14 and 5d10. In the oxidation states, positive 2, Zn positive 2, argon 18, 3d10, cadmium positive 2, krypton 36, 4d10, mercury Xe 54, 4F14, 5d10. The first, second, and third transition series are 27 elements, not 30 elements. The reason for this sentence that zinc, cadmium, and mercury elements of group 2b are not transition elements, as they have completely filled the sublevel in all their free states. In the free states, zinc has electronic configuration argon 18 for S2 3d10, cadmium, krypton 36 5s2 4d10, mercury Xe xenon 54 6s2 for F14 5d10. In the oxidation state, positive 2, Zn positive 2, argon 18 3d10, cadmium positive 2, krypton 36 4d10, mercury positive 2, Xe54 for F14 5d10. So here no partially filled d sublevel in either oxidation state or the atomic state. Next point. Coin edge metal of group 1b copper, silver, gold are transition elements. The reason for that is in free states copper argon 18 for S1 CD10 and ionic state positive 2 copper positive 2 argon 18 3D9. So positive 3 also the sublevel D will be partially filled, D or D9 or D8. Type of question, choose the correct answer. Zinc positive 2, zinc ion 2 is characterized by its diamagnetic property due to what? Presence of 3d paired electrons, 3d sublevel is filled by 8 electrons, 3d sublevel is filled by 5 electrons, the presence of unpaired electrons in 4s sublevel. If you think about it, yes, it will be the presence of 3d paired electrons. Next point. All the following ions are paramagnetic except what? Vanadium positive 2, chromium positive 2, zinc positive 2, iron positive 2. If you think about it, my dear student, you will find the answer is zinc positive 2. This is the only ion here that is diamagnetic, as the zinc has completely filled the sublevel in the ionic state positive 2 also. Next point. Zinc 2 ion is colorless due to what? Presence of 3d paired electrons, 3d sublevel is filled by 1 electron, 3d sublevel is filled by 8 electrons, the presence of unpaired electrons in 4s sublevel. If you write the electronic configuration, you will find that the presence of 3d paired electrons. Next point. All the following ions are colored except what? Vanadium positive 2, chromium positive 2, zinc positive 2, iron positive 2. You will find that the only zinc positive 2 is colorless, as the d sublevel is completely filled in the positive 2 oxidation state. Next point. Iron 2 ion is characterized by its paramagnetic property due to what? Presence of 3d unpaired electrons, the 3d sublevel is filled by 10 electrons, the 3d sublevel is empty, the presence of unpaired electrons in 4s sublevel. The reason for that is the presence of 3d unpaired electrons. Next point. The atomic number of metal, its magnetic moment is 2 equals what? 23 or 29, 21 or 22 or 28 or 27. If you draw the d sublevels that will have 2 unpaired electrons, you will find the answer here. It will be 22 or 28 electrons in the element. Next point. Iron 2 ion is colored due to what? Presence of 3d unpaired electrons, 3d sublevel is filled by 10 electrons, 3d sublevel is empty, the presence of unpaired electrons in 4s sublevel. If you think about the answer, my dear student, it will be 3d unpaired electrons. Remember, my dear students, the unpaired electrons makes the property of the element in the color. It will be colored and also paramagnetic. Without founding unpaired electrons, all the electrons are paired, or the d sublevel is empty, it will be colorless and diamagnetic. Next point. The magnetic moment for the paramagnetic substance increases by increasing of what? The atomic number, the mass number, the number of single electrons, the number of paired electrons. If you think about it, Yes, it will be number of single electrons. Next point. Copper 1 ion is colorless due to what? Presence of 3d paired electrons. The 3d sublevel is filled by 1 electron. 3d sublevel is filled by 8 electrons. The presence of unpaired electrons in 4s sublevel. If you think about it, yes, it will be the presence of 3d paired electrons. My dear students, we have reached to the end of our program today. I hope you understood all the points and different types of questions that we discussed today. So till we meet again, my best wishes for you.